Yes, the figure below is a rhombus. Find its area. Very simple. This is very simple. Pay attention. Pay attention. So we are given this twisted square. Remember, a rhombus is a twisted square. So it was a square, then it was twisted. So once it was twisted, nothing changed except the angles themselves and the diagonals. But all the other measurements, that is the two lines, opposite lines which were parallel, they remain parallel, and the size of the lines, the edges, they remain the same. So the length, now it has become the base, and this, which if it was 20, even here it is 20. You see? Yeah, so it was. So tomorrow you make sure you bring a wire. We make this square, then we twist it. We squeeze it from one end, from this end. We push it so that you can see whether it behaves like this. You can also take it back to be a square. Now, area will change. If the area of the triangle, the square was 20 times 20 to give a 400, now it is going to change because the surface has been affected. It has been affected. Now, let's come here. How do we calculate the area of a rhombus? We have to measure with half d1 times d2. And the other method is this one. You can see the top here. This is the height. This is the height, and therefore it is going to give us an idea on how we can work out the area of this shape. So first of all, maybe we do not know the diagonals because we know area equals to half d1 d2, half d1 times d2. That is the diagonal. The diagonal is here. Look, diagonal is this one here, all the way to there, and the other diagonal here. Do you know the qualities of rhombus? Yeah, diagonals bisect each other at 90 degrees. Yeah, they bisect at 90 degrees. So in case you are not given these measurements, you can use Pythagoras theorem to look for for the area. If you are given the diagonals, maybe you're a part of the diagonal, you can just use Pythagoras theorem. Then you multiply by 4 after getting the area of one triangle, because all the triangles seem to be the same. Now, the other formula for calculating the area of a rhombus is uh, that is base. Where is the base? Now base is this one times the perpendicular height. Base times perpendicular height. Where is the perpendicular height? Yeah, this is the perpendicular height, and this is the base. As simple as that. So then let us work out. Let us work out. Are we going to use this one for d1, d2 over 2, or we are going to use the base times height? Yes? Base times, why? Why are we going to use the base times height instead of using the d1 times d2, then you divide by 2? Yeah. Oh, we are not given the diagonals. All right. Appreciate him. Very well. Now let's come here. So it will be base times height, and this is the base. I will show you why we say it should not be put half, because the moment you put half base times height, that is the area of a triangle. So this is not a triangle. All right, let us prove why do we do base times height. In case you cut here, look, if we cut that part, this part, and take it to this part, it becomes a triangle again. So it goes back to a triangle. So multiply 20 times 12, 20 times 12, 20 times 12. Without using a calculator, it's very simple. Take this 0 here. It becomes 120. So 120 times 2. Very simple. You get 240. Then you say it is centimeter squared because it is area. Very simple.